So today we're going to talk about how tech stacks work. What are tech stacks? Why should you care as a product manager? Is that something that you even have a control over? And if at all you have to bother about it, then what do you need to know about them? Okay, we're going to cover all of them. To begin with, let's play a game. How many of you play this? Right? So you have blocks. Let me try to place them where you can see them, right? What are these? These are essentially blocks, right? The simple blocks which you can use to create pretty much any kind of beautiful building, right? And each of these blocks depend on the layer below it for its stability, for its stability, and for the odds of you succeeding. If the blocks below start moving or they have not been placed correctly, then what ends up happening is you end up losing because they tumble over, right? A tech stack in a technology product is no different. A tech stack is basically a set of tools, set of frameworks, set of libraries, set of programming languages that you have put together so that your product starts working, okay? So just like I'm building my Jenga stack right now, and just like a typical building gets constructed, you don't start with a marble, you don't start with glasses, you don't start with timber, you don't start with furniture. You start with the foundation, right? So you start with the foundation. The foundation depends on what you intend to build on top of it, correct? So if you plan to use that building for very heavyweight work, for example, it's a warehouse where, let's say, I don't know, let's say cars are manufactured. If the cars are manufactured there, then the cars will be hung, the chassis will be hung from the top. So you would need a very different kind of cantilevers set up at the very top so that it can take up a lot of load, correct? Similarly, when you're building a tech stack, the bottom layers are dependent on the top layers, and the top layers are dependent on the bottom layers, right? So it's a loop that you need to break, and you need to define what exactly matters for you, what doesn't matter to you, so that you end up building a tech stack which doesn't tumble over. I believe most of you would have heard of the term tech debt, okay? Tech debt is basically when, as you build products, there's a debt in maintaining the product, right? And the tech debt is inevitable. You will always have some tech debt, no doubt about that. But you can ignore, or you can defer it for as long as possible. If you use the right tech stacks, if you take the right decisions in the early days. Typically, this decision is taken not by the product manager, it is taken by the engineering manager, by the engineers, and so on. But a product manager can influence those decisions very well if the product manager has a clear vision, has a clear idea, knows what the product is going to be in 6 months' time, in 1 year's time, and you would want to build a solution which doesn't incur too much of tech debt, and at the same time, it is not too costly to maintain either, okay? Anyway, let's keep it here, and we'll work on this a little later. So let's talk about what are tech stacks. Any kind of software product, whether it's a mobile product, whether it's a web product, whatever the case be, can simply be considered in a couple of in the form of a tuple. That is, it has client on one end and it has server on the other end, right? So you have, so you have client on one side and you have server on the other side. We discussed this in class 1 as well, that there is client side and there's server side. Effectively, that is all there is, okay? Yes, it is, I'm oversimplifying it, but as you learn over time, that this oversimplification actually holds true even for the most complex products out there, okay? Just the definition of client and the definition of server kind of starts changing. Anyway, for our definition, for our use case, client and server is a good definition. Now, a tech stack is used to construct your server, to construct your client. What is client made of? In the earliest days, or in the simplest fashion, client side has simple layers. So you have HTML, you have CSS, and you have JS. Okay, very simple. And on the server side, you have few other things. So you have, for example, number one, you have the server itself. I will explain. Sorry, I'm sorry, not server. It's the OS at the actually the very beginning. So you have OS to begin with. That is the operating system on which the server is working. Then you have the operating server. The server. I'm sorry, I'm kind of zoning out. Yes. So you have the server on the second hand. Then you will have the programming language on top of it. Okay. And then on top of this, you might have some load balancers, you might have some other things, but at the bare bones, you will have the server, you will have the operating system and the program. Okay. This is actually number one, this is number two, and this is number three. I kind of mixed it up. Okay.
I think there's a framework
Now,
as well.
we will come to that. Yeah, please put it on the chat and we can pick that up. Okay. Yeah, no worries. So you have client side, you have the server side. Okay, in the simplest fashion. Now, obviously, things are not as simple as it seems, and I'll start with the client side first of all. So you have HTML. What is HTML? HTML is basically a skeleton. Okay, I will in a brief, in about 10-15 minutes, I will actually show you how HTML looks like, how CSS looks like, and how JS looks like on one hand, and I'll also try to show you the server side, and I'll try to deploy something so that you can actually see how it actually comes together. So HTML is basically a skeleton. Think of it like bones, right? You need the bones in some way so that your hands and legs and everything else are in a certain shape and size. That's it, right? So HTML covers the skeleton of the product, of how the product is going to be viewed at the client end. Okay. CSS is how things look. Okay. So it controls the look and feel of the product, of the view, of the interface. Okay. Let me not call it the product, but the interface. The interface is controlled by the HTML and the CSS. HTML gives us a structure. For example, when you're constructing a house, you would set up that, okay, this is my living room. You will simply make a brick wall. This is my bathroom. You will set up a brick wall. You will set up some holes and some punctures and some plumbing and everything so that the bathroom looks like a bathroom, or actually, sorry, works like a bathroom. And later on, CSS determines whether your house is going to look like a mid-century modern, or it's going to look like Gothic, or it's going to look Indian earthen, right? Because the CSS determines whether you're using wood, you're using marble, you're using glasses, you're using what color, you're using false ceiling, you're using something else. So CSS determines that. And finally is the JS, which is JavaScript. And JavaScript determines how it functions, or how the interface works. Okay, what that means is, now how do you enter the house? You have made a beautiful house. You made a entry point. You made a place for the door to come in. Now the door is made of like mahogany wood, beautiful looking door, shining door with everything else in place, which is that CSS working there. But if you have not installed JS, or if you're not using JS, then effectively the door lock is not working. It's not functioning. The door lock is not closing, right? It's just a door. That's it. Correct. So JavaScript is required for plugging everything. So when you click on a button, when you enter some data in the field, when you are interacting with the interface in any way, you're essentially using JS. Now, all of this, the HTML, CSS, and JavaScript, are constructs used for setting up a web interface. Okay. Okay. While for a mobile interface, depending on which mobile platform you're looking at, so on iOS, you would be using Swift. Nowadays, it's all Swift. Earlier, it was Objective-C. And on the other hand, on Android, You can use Java, you can use Kotlin, or you can use some other new languages, frameworks that are coming in. Okay. Now the Android, the iOS, or the web interface, or let's say PWA or web response, mobile web, for example, all of these different formats, these are all the client-facing interfaces. That is the client that is powering or that is triggering whatever is the client is actually using, right? And on the other hand, you have the server side. Okay. Now the server side is constructed of multiple layers, similar multiple layers. So at the very bottom, or let me put the bottom at the top because that will be slightly easier for me, is the the OS that you're using. So OS, for example, if you're using, for instance, if you're using Ubuntu or a Linux, then very different kind of servers you'll be accessing. Versus if you're using Microsoft or you're using Apple, the server will be very different. That is the software that you're using to serve the site or serve the response is going to be very different. I'll cover the server and everything in a bit. Okay, specifically what server means and what is its job. So then you will have the server. On top of the server, you will set up few other frameworks. These frameworks are consisting of multiple different ways, but in very simple terms, you have the programming language, okay? And then you have the DB, the database, okay? So there is an operating system at the very bottom, there's server, and then the server ke saath mein there's a programming language, there's a database. Now, let's break this down. What is the purpose of OS? What is the purpose of server? What is the purpose of programming language? What is the purpose of database? So operating system is operating system. Its job is to make sure the systems work. Okay. So these come in different flavors. Like I said, there is Microsoft, there is Apple, and there is Linux. Linux by far is the biggest, has the biggest market share. I think it covers almost 86% of the entire server market. Now, Linux by itself, for those who don't know, Linux by itself is broken down into multiple frameworks, multiple. DB is not part of the OS. The operating system's job is simply to put things together. Okay. So Linux by itself is broken down into multiple different flavors. So Linux is one of the most popular ones is Ubuntu, but then there is Red Hat, there is Kubuntu. If I actually start listing all of them down, I can finish the entire session. Okay, there is Lubuntu for those who don't know. There is Pingu, right? There's a whole variety of them, but the most popular one are Ubuntu, which is very easy to use. A lot of people use them, and it's fairly easy. They have tried to simplify it, and they've tried to build it and as an alternative to Microsoft, for example, for Windows. Red Hat is a little more enterprise-y to use. There's a whole other ones which I'll not cover. I'll just cover Ubuntu here because Ubuntu is the one which you'll most likely be using, or you will be most likely experimenting with. Okay, so operating system is pretty much like your Microsoft or your Windows or your Apple, which manages your file systems, which manages your input output, which manages the RAM, etc., etc. It puts all of these things together. Now, you would install a server on top of this. What is the job of server? The server's job is to accept an incoming request. Okay. Accept request, send response. That's its job. Okay. So server, by the definition, by the name itself, namesake itself, its job is to serve the request. Okay. So let me talk about the life of a typical server. The life of a typical server is very thankless. Nobody cares. Nobody knows. The server is doing so much of work. Right? So this is a humble little server sitting in some nondescript data warehouse. It could be in AWS, it could be in Azure. Don't worry, what is AWS, Azure? I'm going to cover that later. But it's little server beeping, booping silently somewhere. And here is Mr. Bob, who decides, I want to watch something. I want to watch Netflix, right? He's bored in the house. And Bob decides to switch on Netflix. Now Netflix gets a request that Bob wants to see a movie. So Netflix decides, Netflix says, okay, I need to figure out what Bob should be seeing because I don't know what Bob likes to see. So Netflix sends a request to the humble Netflix server. Okay. Now Netflix server accepts his request, reads it, which says, Bob wants to see something. Tell me what should we show to Bob. Now Netflix server, okay, Netflix, this server or this machine is composed of the server by itself. There is a programming language, right? There is a database, and then there is a whole bunch of other stack of things that we will not get into. There are about 20-25 other products that they use altogether. But right now, for simplicity, the server accepts the request. Nobody else can accept the request. Database cannot accept the request. Programming language cannot accept the request. Server is the one which accepts the request. It's his job. He's a gatekeeper. The server accepts the request, reads the request, and then figures out, okay, we don't know what Bob needs. So let me ask the programming language that, hey, can you find out from the database what Bob would like to see and what Bob has seen earlier? Programming language says, okay, yes, give me a second, I'll just check it out. Programming language goes to database, fetches some of the information, does some calculation, and then takes it back to the server. Server says, okay, great, thank you so much. Thank you guys for the teamwork. And then server sends it back. There's a response, okay, which goes back to the Chrome browser. If Bob is using Chrome browser, goes back there. The Chrome browser reads in the simple HTML format, just a simple HTML, CSS, everything comes together as a blob of text, and Chrome reads it and renders it. And all of this beauty happens in few microseconds, literally in few microseconds. Okay. So server's job is essentially to accept the request, read it, understand it, process it, and pass it back with a response, with a suitable response. If, let's say, the server is not able to process, is within a certain time frame, if the server is not able to figure out what to send back, then there is something that happens which is called timeout error. Okay, the timeout error, I think there are different codes for each of these errors. The timeout error happens when, let's say, the programming language is not able to process. It got stuck because there was so much of information that was asked and programming language was busy, so it couldn't figure it out. Or there was not enough RAM to actually process whatever the information was asked. Similarly, the database was busy. There was something else was happening. Correct. So there is 503 error that happens, right? On the other hand, if the information was not found itself, then there's a popular 404 error. But sorry, there was no information found. Who is Bob? Right? He's a wrong guy, or he's requesting for the wrong movie, or something like that. Or let's say, the movie that Bob is requesting for is not allowed for him because he's 10-year-old and the movie he's asking for is not meant for him. It's not safe for him, right? So then some other error can be thrown, right? But broadly, this is the job of the server. Now, let's go slightly deeper. This server comes in different flavors. There's the grand old daddy, which is Apache. Okay, Apache is the grand old daddy. Apache has been around since a long time. I think it covers about 60-70% of most of the servers out there. There's a very good likelihood. Oh, no, you are using Zoom right now, so Zoom is mostly on another platform called Nginx. Okay, which is very, very popular now. Nginx is a much more lightweight version of a server. So think of Apache as a software which accepts certain requests, processes it, reads it, understands whether it has what should be done with that request, passes it to the right people, then waits for them to do their job, come back to Apache that's saying that, hey, I have done this work and now pass it back. And Apache says, thank you, sir, let me pass it back, and then passes it back. And that's the job of Apache. It's a good old traffic policeman, if I may. Nginx does the same thing, except Nginx does it slightly faster. It's a modern, cool DAD, effectively, a modern cool machine or server that kind of does the same job. Then comes then Microsoft has its own version. I think it's called IIS, if I'm not wrong. And then there's Apple has its own server. Okay, but Apache and Nginx are the most popular in the wild. Okay. For those who remember the previous class in Apache, so what really happens is at the client end, when Bob sent a request, essentially the request was sent in the form of a message, which was broken down into packets, right? There were small packets, and these packets were then routed through different IPs and different routes, right? It was routed, and all of this information was then ultimately reached. It reached the final IP of, let's say, Netflix server. At this IP, I'm simplifying this right now, but there are load balancers, there are security protocols, etc. A lot of those things are there. But assuming that all of those things are all sorted, at this IP there is a server. I'm assuming that Netflix uses Nginx. So this IP, at this IP, Nginx is sitting and saying and trying to figure out what to do with this request. So this packets reach, they are assembled back up. They're assembled and the message is deciphered that, okay, this is what the Bob was asking for. And so Nginx then passes this information to its programming language. Now, when in Netflix case, programming language, if I am not wrong, programming language behind the scene is Ruby. Okay, what is Ruby? I'll talk about that. So it's actually Rails to be more accurate. So Ruby on Rails. Rails is the framework. Ruby is the language. And this Ruby on Rails then works with, it's a combination of Mongo plus MySQL, if I'm not wrong. I think Uber has moved back to MySQL while Netflix is still on Postgre. Doesn't matter, the concepts remain the same. Okay, MySQL and Postgre are the databases. Okay, this is also a database, but this is a different breed of database. I'll come to this. Okay, so this is broadly what happens behind the scenes, and then Nginx gets the information from the database and the language and sends it back to through the IP back to Bob. Okay, clear so far? Any questions right now?
Talvinder,
Yes.
so Zaid there. Am I okay to ask on speaker?
Yeah, please go ahead. Go ahead.
So you are talking about like it's routing through, I mean, from that NGNX, right, to the MongoDB. So, but in most of the cases, like for example, I'm like currently working on that application development. So it's like I mean, maybe, I mean, just for generalization, I mean, you might have, I mean, skipped that part. But isn't that like in between API layer is always most of the 90% of the codes does have a API layer which in turns with interact with different DBs or any other external systems they have to interact?
You're absolutely right, Zed. So there are layers in between. So effectively, what I'm talking about right now is a very old school, simplistic product where there's a single HTML file, there's a single CSS file, there's a single JavaScript file. They're working together on, let's say, an Nginx or an Apache scenario. Right? I've not even spoken about the JavaScript frameworks, for example. Nobody uses HTML, CSS directly nowadays, for instance. Similarly, there are, so for those who are uninitiated, who do not know what I'm talking about or what Zaid is talking about, pretty much at every single arrow that you're seeing, there is a friction, there is a interface that kind of connects the dots. Okay, so between this IP to transfer of data to Nginx, even between these two things, there is plenty of layers. There are at least 2 or 3 other layers which come into picture. Okay, but it is beyond the scope today. Today, you just need to understand how information just flows. Okay, so we'll talk about API layers. We'll talk about each one of them one after the other. Okay, right now just bother about how this system actually kind of works together. Sure.
Hi. Could you please tell me about the packets? What is it, packets?
Packets, we will talk, I mean, we have covered in the previous class. So if you just check that out, you will understand.
Sure, sure.
Right. So think of just as a message which was sent, but the messages cannot be sent together. Message needs to be broken down into smaller bite-sized packets so that it's easier to send them. Okay.
Okay.
Okay. Chalo. Let's move on to the next segment. Let's talk about some existing stacks. Okay. Let's understand some of the existing stacks. Right. Okay. I believe you can see my screen. Just give me a yes or no.
Yes, yes.
Okay, awesome. So this is a fantastic roadmap which talks about the front-end developer. So basically, just to give you a quick, so what I was talking about sometime back about HTML, CSS, JavaScript, that consider that as a 10,000 feet view or 15,000, maybe even 20,000 feet view of how a typical web application kind of comes together, right? But in 2020, this is pretty much where things start, right? If you want to build a front end, you'll start from literally from the internet. You will go into HTML, CSS, JavaScript. You'll have to understand version controlling systems. Then you will understand package managers because you will be talking about HTTP. Because you will be talking about yarn on NPM. NPM is used for Node. Yarn is used for something else. I forgot. CSS is not CSS anymore. There is architecture on one hand. There's preprocessors on the other hand. There are task runners on one hand. There is module bundlers on the other hand. There are linters and formatters. There is a framework, which is Angular, Vue, React, and there's a whole, really large audience. There's a very large audience which is, which loves React versus people who swear by Angular and so on. Then there's modern CSS, which is JavaScript and CSS. So it's a crazy world out there now. Okay. What I've explained to you is the simplest format, which is HTML is the structure, CSS is the look and feel, JavaScript is the interaction. But actually to build a Netflix kind of application or Spotify kind of an application or Facebook kind of application, a lot of things is happening behind the scene. Okay. We can't practically cover everything, but if you have understood this part, you will start understanding a lot of these parts gradually. Okay. You just need to understand how these work. You don't need to understand how to code. Okay. There are CSS frameworks, there are web components, there is type checkers, there is server-side rendering, there's client-side rendering. It's a beautiful world, okay, to be very honest, a beautiful world. The static site generators, Next.js is very popular, Gatsby is very popular, Nux is coming in, WooPress is coming in, Jekyll has been there around since a long time. There's Flutter, which is Google's response to React Native. React Native is very, very popular, but Flutter is catching up really well. Ionic is kind of dead now. I mean, not exactly dead, but Ionic is, it has found its own niche. It is not as great as it was supposed to be. And then there is WebAssembly for desktop applications. Electron is one of the most popular ones. There's Carlo and there's Proton.NET. So this is not meant to scare you, but this is just to give you a quick perspective of how things are. This is a very good site for those who are trying to understand these things. Roadmap as such, it literally started from a single Medium article written by one guy who wrote this front-end development roadmap. And gradually, because this was pretty nicely done. So similarly, there's backend, which I just covered. There's OS, then you have version controlling system, there's Git, there is repo hosting, there's relational databases, which is MySQL, Maria, MS SQL, there's Oracle, there's Postgre. Postgre has found a lot of following. MySQL is considered the old daddy now. There's NoSQL databases. I'll cover NoSQL, I'll cover relational, non-relational sometime. But Mongo is very, very popular. There's Rethink, there's Couch, there's Dynamo. But Mongo is considered one of the best ones. Then there's ORMs, there's acid, there's transactions, there's a whole bunch of APIs. Without APIs, there's nothing nowadays. So within APIs, again, there's SOAP APIs, there's JSON APIs, there's REST APIs. There's so much happening. There's Redis, there's Memcache for caching. There's CDN, there's server side, there's client side. On the server side, you will have Redis and Memcache. Redis is very, very popular. You can use that. Then you need some amount of web security. You might remember MD5. I covered a bit of MD5 in the last class. There's SHA, there's script, there's bcrypt. These are all the hashing algorithms that exist. There is CORS. CORS kind of ensures that the request is coming from the right places only. There's SSL TLS. I covered a bit of this yesterday, the last class. HTTPS, content security policy, etc., etc. There's CI/CD, continuous integration, continuous deployment, etc., etc., etc. It's a beautiful world. Elasticsearch, Solr. There's Elasticsearch. There's also Sphinx, a bunch of other search engines that exist. So don't worry. The idea is in the classes to come, I'll be covering each one of them one by one. Okay, not all of them, but as much as possible. Okay. From this entire vast world, by the way, I spoke about Apache as the web server. I have covered about MySQL somewhere at the top, right? Right, and then there's whole sort of programming languages which kind of I don't think they have covered here somewhere. Yeah, they've not exactly covered it anyway because programming languages kind of go in its own. They are a beast of their own, right? Yeah, okay, they have covered a little bit. They've just covered JavaScript, Python, and Ruby, the three, but there is a whole bunch of other ones. There's PHP, the grand old daddy. Okay, yeah, sorry. It is here, sorry. There's Go, there's Rust, there's Java, there's C#, or C Objective-C, there's C Sharp, and there's PHP, there's JavaScript, there's Python, Ruby. Now, JavaScript has come, from being a underdog to pretty much, an elephant of its own, because JavaScript gained popularity because JavaScript can be used in front end, can be used in back end, and now JavaScript can also be used in CSS itself. In fact, in HTML also, right? So pretty much everything is JavaScript, which kind of makes it very easy to have just one type of engineers which can code everything, front end, back end, etc., etc. Otherwise, you will have to have different engineers who are good with back end, good with front end, and so on. Okay. So I just wanted to give you a very quick overview of what it is. Don't worry if this scandalized you. We'll be covering all of these things one by one in classes to come. Okay. So there's plenty to cover. But anyway, let's jump into what are the different tech stacks. Okay. So this is a very good site called StackShare where engineers and companies, especially there is nowadays all the tech companies have developer advocates. Or developer evangelists, right? Because they want to capture the best of the developers. They want to get as many developers as possible, as fast as possible. So developers like to work at companies which are, smart, which are early in their, which are doing cutting edge work, so that they can. If you're as a developer, if you're working on the cutting edge work, then obviously you can charge much more than, let's say, if you're working on PHP, for example, because PHP has been around since a long time. So StackShare is a pretty good site to explore what is happening at other places, what kind of stacks are being used. So let's quickly just go through this different tools, and I'll try to give you a very good overview of what stacks are made up of. Okay. So if you realize, first of all, Uber is not just Uber app. Okay. There is Uber at the core. Then there is Vault.Uber, which kind of covers a bunch of products. There's a separate product called Vault.Uber, which I think is meant for all security services. Then there's Partners.Uber, where Uber partners, I'm not talking about drivers, but Uber partners like vendors and all, they can actually access this product. Then there is riders.uber.com. That is riders, if they want to use Uber, how can they use it? Then there's a help desk for Uber. There's a business.uber that they'll be exposing business stakeholders with some product, some interface where they can interact. And then there's developer.uber. So developers can access Uber services as well with some of the stack. So let's jump into the main one. Let's jump into this one. There are a whole category of different products, which is put together. So there's application and data, and I'll just go through this slightly slowly because there's a lot to decompress here. So there's application data, there's utilities, then there's DevOps. You can see here, there's DevOps, then there's business tools. Okay, so there are 4 categories in which they have divided. Okay, let me just put them together. Yes. So there's application data, there's utilities, DevOps, and business tools. So application data is the core application which Uber has built. Okay, let's decompress this. So there's jQuery. jQuery is a front-end client-facing framework. which is used for web interfaces largely. Okay, it uses the core JavaScript. Okay, JavaScript is, I told you, it's an interaction library. So jQuery is built upon JavaScript, but it abstracts out a lot of JavaScript's complexities and makes it very, very easy to run. It's pretty much like, you want a burger, you can construct your own burger by going to a supermarket, buy bun, buy the grocery items, buy the patty and put them together and then eat the burger. Or you can simply go to McDonald's and you can get the burger, right? So jQuery is kind of doing that. It's abstracting out a lot of complexity within JavaScript to do simple things, right? I'll not get into details of that. That is not part of the scope of this work. Then there is Nginx. I told you Nginx is a server which does the job of a server, takes in the requests and then provides the response. Python is the language, the programming language, which understands the request that has come in and processes the information, collects the data from database, collects the information from the different Redis and from all the different applications that that needed to collect the data, and then constructs a response and sends it back. Okay. Node.js is another server-side language which is used for similarly accepting the request, processing the information, and finally sending the response. React is a front-end framework. Okay, it's a front-end JavaScript framework. So I spoke about HTML, CSS, JS. So React essentially is a JavaScript framework which abstracts out the HTML, CSS, and JavaScript to some degree, and makes it very, very easy to construct a very responsive front end. Okay, what is the benefit of React and what is the benefit of HTML, CSS, etc.? Again, it's part of the future classes. Right now, just take it, just understand that these are different frameworks, and HTML, CSS, etc. is pretty much the building blocks over which all of these frameworks kind of have been set up largely. Then there's Java. Java is again a backend technology. Java is a language and kind of serves as a server as well. MySQL is a database, Postgres is a database, Mongo itself is a database. Amazon EC2 is a hosting server. It's a host. Let me just call it a host, not a hosting server. So Amazon EC2 is a host. In the old days, what people used to do was people used to buy machines, very heavy, expensive machines, pretty much like you would buy your desktop, old school desktops. So these used to have CPUs, memory, and everything else in place, and people would install in their data warehouses or data centers, from where they would run their sites. I'm talking about 1990s, okay, early 2000s, right? And even today, for example, places where data and data sensitivity is very important discussion. You would not host it on Amazon cloud servers. You would host it internally. Okay. For example, Aadhaar most likely is not on any cloud server. There's a dedicated data warehouse that has been created in which all the data resides. Okay. Then there is Redis. If you remember this a little bit, I mentioned Redis here. Redis is on the server side. It does the caching bit. Okay. What is caching? Caching is basically if the same request is being asked again and again, if the same question is asked again and again, let's just cache the data. Let's keep the response there for some more longer time, so that if there are 100 people asking the same question every second, then we don't have to ask the same question from the server and from the database again and again. Okay, that is broadly the idea of caching. And caching can happen on the client side. So if this person on the client side is asking the same question again and again, let's keep it on the client side. Okay, so that we don't even have to bother the server with the same question, right? And if the question cannot be answered or cannot be cached on the client side, then you would go to the server side and you will cache the data on the server side. Okay. So think of this request and response as a series of questions that a client asks the server that, hey, can you give me this file? Yes, please, I will give you. Can you give me this data, please? Oh, sorry, I also forgot. Can you give me this image also? Right. And then the server will get bored after some time and say, hey, I have created this stock. of images and the data, etc., which I believe you will most likely like to have. So don't bother me. Just take from this stack, and if this stack doesn't have it, only then ask me. That is pretty much what caching does. Okay. I'll go back here. So MySQL, Postgre, Mongo, all of them are databases. Python, Node, and Java, they're all backend programming languages. Amazon EC2 is the host on which all of this machinery is working. On Amazon, you can install anything. You can install Ubuntu, you can install pretty much anything. Okay, it doesn't matter. Right? Then they have used Go. Go is a language which was created by Google, and Go is attributed. Go is considered one of the fastest languages right now in programming languages. It does a fantastic job at that, but it's slightly more complex or difficult to understand compared to Swift and a few of the other ones which exist. Python, for example. Then there is Swift. Swift is used for front-end iOS apps. The front end of the iOS apps is made out of Swift. Then there's Kafka. Okay, Kafka will require a little extra explanation. I'll not go into that. Objective-C is the precursor to Swift. So earlier, Objective-C was a language in which iOS front-end client-side code used to be written, which was then Objective-C is still supported, but it is on the way out. Swift is the new language, which I think was introduced about 4 years back, 3 to 4 years back, or even 5 years back, I think. And Swift is mixes Objective-C and JavaScript. It kind of uses the beauty of Objective-C and of JavaScript to create its own language. Then there's Backbone.js. Backbone, I forgot what it does. I'm not sure if it's a front end or a back end framework. I do not remember that. Cassandra is a beautiful little tool, which is a little more complex to explain. So I'm not going to go there, but I'll cover that in the future. Same goes to Thrift, same goes to Spark. But you can see Apache does a lot of good work. Okay. Similarly, Ares DB is again one form of databases, but I'll not go into a lot of these very particular use cases because I'll have to explain what is Cassandra, where exactly it works, etc. We'll come to that later. Okay, thank you, Keshav. Backbone.js is a front-end framework. Thank you. So this is all that powers the application and the data side of things. Okay, you might have a question that why are they using these many databases? MySQL, Postgre, Mongo, and then there's Ares database as well. And on the other hand, there's Java, there is Python, there is Node, there's there's so much of stuff that is going on. And in the front end framework also, they have so many frameworks. They have Backbone, there's React, there is Go, there is Swift. What is happening here, right? So what it is happening here is that so Uber is not an easy application, right? There is Android, there is iOS app, there is a web app, there is there are whole different applications, and each of these applications are best served by a different combination of stack. Okay, so they might be using, for example, they might be using Java for one particular reason because Java does one thing really well. Versus, let's say, for example, Node does something else very well, right? Python does something else very well, correct? Now, what do they do very well? Keep it in the backlog. We will cover that later. But each one of them are specialized languages. While they can do a lot of things, but when it comes to Uber kind of performance, then you need to use them in a very specialized manner. Right? It's pretty much like using the kitchen tools for the right thing. While you can use a big, thick knife for pretty much cutting anything, but if you really want to, create, very tiny cucumbers, then you cannot use, a butcher knife. You need to use the tiny knife. I don't know what the tiny knife is called, but you need to have you need to use the tools very carefully, and that is why. And at Uber scale, you would use the languages in a very specific, precise manner, right? It's pretty much like a surgeon performing its activities. It's, so they would use things very carefully. Now, on top of this application and data, you have all of these utilities. So Google Analytics for simply analytics, Elasticsearch for searching through all the doing search across the databases, right? And you need a very high performing search engine, and Elasticsearch does that job pretty well. You can also use Solar, you can use Sphinx, you can use a lot of other tools, but Elasticsearch is proven to be pretty popular. PayPal for payments, I think PayPal is being used for largely transferring the payments to the drivers and to other vendors. Twilio SendGrid. SendGrid is used for all the emails. Okay, it's a transactional email platform. Okay, it's a transactional email platform. It is used for sending emails. So all the emails that you get from Uber most likely are coming from SendGrid. Mixpanel is another analytics tool, and it is used for tracking events that you as a rider or somebody else as a driver is performing on the Uber app. So Mixpanel is a beautiful analytics tool, pretty much the first analytics tool out there, if I remember, which started using event-based analytics as to why something happened, trying to answer why something happened instead of what happened. So Google Analytics is used to be all about what happened, that, hey, this has happened. I don't know why, but hey, this has happened. My job is done. While Mixpanel was focused much more on why it happened, what was happening, what was the behavior, what are the different events that happened that led to something. Okay. Twilio is a telecommunication company, and Twilio does phone calls. Twilio does so Twilio started off as a programmatic SMS and programmatic call service. Gradually, it has become a communication stack altogether. So you can do live streaming, you can do a whole bunch of things. Optimizely is used for optimizing interfaces. Okay. Crazy Egg is again optimization. TensorFlow is an AI modeling platform, crudely put. Okay. There's Heap, there's Braintree. Braintree is like PayPal, it's a payment gateway. HackerOne, I'm not sure what it is. Ludwig, I'm not sure what it is. There's so many things that are happening, right? Heap is again big data analytics. Then you have DevOps. So now, if you have to run these many tools, to be very honest, running a simple LAMP server itself is a pain. Okay, just using LAMP server. LAMP is Linux, Apache, MySQL, PHP. A simple server or a simple stack which has Linux, which runs on Linux, which uses Apache as a server, which uses MySQL as database, and which uses PHP to code. So WordPress, for example, is a LAMP server. Even that itself becomes a nightmare if you have, let's say, 10,000 or let's say 1 million users. You have to do so much of optimization. You have to do caching, you have to do this, you have to do that, etc. So as the product becomes popular, the complexity grows, and you need a lot of DevOps tool. And honestly, DevOps tool is a jungle of its own. I don't know half of these tools, and you can get lost very easily. But you can see easily there are two tools which Uber has built by itself. One is called Kraken, very popular now. There's another called Uberalls, right? There's Terraform, there's Grafana, there's Require, there's, oh my God, it's a jungle out there. I'll not go there. And then there is business tools. That is what exactly happens internally. How do business stakeholders actually manage all the work that is going on in Uber? So Mattermost was a very interesting discussion that Uber also covered. Mattermost is alternative to Slack. It's open source. So so Uber moved from Slack to Mattermost to take care of all the thousands of riders as well as company employees that they had. So they moved from Slack to Mattermost, and there was a whole discussion. It is an amazing article that was where they covered their decision on Mattermost, right? So, if you read here, The Road to UChat, building Uber's internal chat solution, if you read this article, you will be blown away. The amount of stuff they have covered is incredible. You might not understand a lot of these things, but that's perfectly okay. You will start somewhere, and you will eventually get to that point where you will get very, very good, and you start understanding a lot of these languages, right? I covered XMPP and Erlang and some of the stuff in the last class, right? So if you read this, they actually did, they looked at all of these database locking, they looked at tech stack, blah blah blah, their Puppet deployment, their current Puppet deployment, etc. This is what a typical server looks like. But yeah, so go through this. If you really want to, get sleepless nights, please go to Uber's engineering blog, and you'll get a lot of sleepless nights. I have, right? So this is just one part of things. Let's go into one more. let's say, okay, let's jump out of Uber. Let's go to something else. Let's browse some more stacks. The popular will be Airbnb and Uber and maybe something else, maybe Google, for example. Okay, there's Pinterest, there's Airbnb. Let's go to Airbnb, for example. Right now, Uber's tech stack is extremely demanding because it's very transactional. Like so many drivers coming, going, etc., etc. It's a demands a lot of work. Airbnb, on the other hand, has a different problem altogether. Here again, they're using JavaScript. They're not using jQuery, for example. jQuery is not used here at all. They're using Sass. They're built on Ruby, which is Ruby on Rails. So just understand for the time being that there are frameworks for pretty much everything. For HTML, there are frameworks. For CSS, there are frameworks. What are frameworks? Frameworks are meant to templatize certain amount of action. Okay. Because if it's already well known that in pretty much every application or for every programming language, you would be using it for, let's say, storing some data, or let's say for seeking certain data, or let's say for authentication, for instance, right? So you start using certain frameworks which would abstract out those common activities so that you don't have to write it over and over again. Okay. I'll not go into deep of each one of them, but I'll just quickly cover them. You can easily go by yourself and you can start reading about them. If you just click on them, you can easily read what Nginx is. So Nginx is server, and like I said, JavaScript is a language which is used nowadays in front end as well as in back end. React is React and React Native are two different languages, by the way. React Native is used for mobile apps, while React is used for websites. Okay, for web for desktop experience, for web experience. Java is Java. It's a language which is designed for it's a backend language on which you can build solutions. MySQL is database. Amazon EC2 is a host. EC2 stands for Elastic Computing something, I forgot. Redis is again cache. Amazon S3 is like a folder on which you can store any data. It's a cloud folder of sorts. Ruby is the backend language on which Airbnb was largely built. Sass is a CSS framework. Amazon CloudFront is a CDN, which kind of sits in between you and the server, so that all the common data, all the common media files can be served from CloudFront instead of from the server. So server is used only for the most mission critical stuff. The RDS is again database, but it is built on cloud and not on it's not a separate machine altogether. Then there's Elastic Cache, there's Airflow, there's EBS, there's Druid, Presto, Airpal, etc., etc. Right? So you can see again the common, motley crew. There's Wingify. This is an Indian product, by the way. This visual website optimizer is an Indian product. This Lottie. Lottie was made by Lottie is a beautiful product. And in fact, most of the animation, micro animations that you must have seen on apps, website, as well as on mobile apps, they are coming from Lottie. And you have a whole bunch of other products. I'll not get into the detail of this, but I think this gives you some sense of how the different stacks are assembled together. And typically, companies like to reduce or minimize the number of products they are handling in their stack. Okay. On the other hand, developers like to work on the shiniest little thing. Whatever new shiny thing comes in, they would like to work on it. And that's where the kind of balance starts coming in. That developers would want to use as many new products as possible because, hey, by using PHP, so PHP was cool, let's in 2004 when Facebook was coming up and Facebook used PHP throughout. In fact, PHP is still on, Facebook is still on PHP, but heavily modified, tweaked PHP. In fact, one of the formats of PHP that they use is called hip-hop PHP, right? Yeah, so you can actually see PHP. In fact, one of the only large-scale companies out there which uses PHP nowadays. I love PHP. I don't have a problem with it, but a lot of people have. So it's built on PHP. On the front end, they built React. They built Hack. Hack is a, you can see, hip-hop virtual machine that interoperates seamlessly with PHP. So HHVM stands for hip-hop virtual machine, which was designed for running PHP really fast because PHP doesn't run very fast, right? So, So in a nutshell, you can scale pretty much anything if you really have the money and the enter to do it. Facebook has done a lot of very good stuff. Origami came from PHP, from Facebook, for example. React came from Facebook. React Native came from Facebook. HHVM came from Facebook, for example. So a lot of these machines, a lot of this stuff came from Facebook, and they have been able to scale PHP to 1.3 billion users, which is incredible. No, I think they are at 2 billion now. I don't know. If you add all of them up, I think there's even more, right? So anyway, the idea was not to scare you guys, but the idea was to tell you that it's a jungle out there. And if you really want to understand every little thing, you can spend a month easily on just reading up on all of them. I find it very fascinating. You might call me weird that what is fascinating about this, but I find it very, very fascinating about learning about the different tools, different things that are out there and what do they do, etc. I still do not have a complete grasp on a lot of things. So Sentry, if you remember, Sentry I was covering. Sentry was as a utility in Uber. It was a utility in, I think, in Facebook also, in Airbnb also. Sentry by itself is here. Postman is, I'm happy to see Postman here, by the way. Postman is a Indian product made by a couple of few developers and grew very, very prominently. Postman uses Postman, which is beautiful to see. There is Nginx, which is a server. Bootstrap is the client framework, presentation framework. What it is, I'll explain that later. Underscore is another, I think it's a JavaScript templating language. MaxCDN is a CDN. Stitch, I have no idea what it is. Stitch is all the data. I think it's some data. So I don't know. And then they have, I think they have not covered everything. They have not covered their, they have not covered which databases they're using, etc. They've not covered a lot of this stuff, right? But yeah, they're just getting started. They're using Redshift. Okay, they're using Looker and some of this stuff. But anyway, so I hope this gave you some sense of what tech stacks are, right? And what are they consisting of? And I kind of brought you down to the jungle of these different tools. And I will leave you, you know, so this was essentially our tech stack, right? So if you're just starting up, perhaps you'll just use 3 tools, right? Maybe you'll just have a database, you'll have a server, you'll have the PHP language, you'll just host it on, let's say, AWS, and you're good to go, right? But as your product starts scaling up, as your product starts being liked, you'll start realizing you need layers on layers. So you can't really rely on, so that is when things start moving. So you'll start removing piece by piece that, okay, the previous machine or the previous instance, this was doing its job, but now it's outdated. Let's throw it and let's introduce something else, right? And we will try to fit it in, and hopefully it fits in, and then everything is good. If it doesn't fit in, it will introduce some tech debt. So while introducing it, we realize that, okay, something else fell off because this earlier block used to work with this block, but now with this new block, it is not compatible with this block. So now your tech stack starts wobbling around, right? Things start wobbling around. You'll start removing certain things because they don't serve the purpose very well. They're not scalable anymore. You'll start dropping them down. You'll start replacing, patching things here and there. Just like when Facebook started with PHP, simple. And as people started adding up and PHP got popular, things were not as simple as earlier. So they started changing things, moving things around. And ultimately, most of the companies out there are essentially a Jenga kind of a stack where things are all over the place and you don't know what will topple over when, okay? And that is why the DevOps and everybody is just day in, day out, they're trying to keep everything sane, okay? In Uber, etc., they would build AI tools on top of things so that they can detect failures of their machinery and failures of things as fast as possible. They will build they have built a lot of work actually, which automatically rolls back to a previous version if the number of errors reported in the new release goes beyond a certain threshold, right? And why is all this happening? Because by default, everything is broken. It might sound very scary or funky, but that's the truth. Everything is broken. Everything is just a patch of a patch of a patch, okay? I just showed you the whole 55 different products. Out of the 55 different products, almost 90% of them are open source. These open source products are built by largely by volunteer developers, right? And there are patches all over. Okay, so if something goes wrong, everything can go wrong, right? So all the beautiful machines and all the different products that you're using, Zoom or pretty much anything, they're underlying on open source products. I personally love open source. I'm not saying that they're bad, but I'm just saying that this decision of tech stacks is an ephemeral decision. It does influence the eventual tech debt that you will have, the eventual products that you will end up building, the eventual work and the kind of developers that you'll be working with, the kind of developers you'll be able to influence and you'll be taken. For example, if you're using PHP, there's a good chance a lot of modern developers would not like to join in simply because it's not cool, not because it's not as good. It is good for it, what it does, but it is not cool enough. So you might want to use React or React Native. But then the problem is there are not enough React Native developers who can do a very good job. So then if you do not have a lot of money and you can't pay that kind of work, then you'll have to settle in somewhere in between, and you'll start figuring out, should I take in people from PHP background and ask them to train them into React Native, or get in React Native people, right? So there's a whole bunch of these decisions which come into picture. As a product manager, you'll not be influenced, or as a manager, you'll not be deciding the finality of the decision, but you'll be influencing the decision based on whether your solution that you're looking at, is the solution going to be scaling up to 2 million people in 2 months, or to 2 million people in two years, for instance? Or the entire roadmap of the product, is it going to be very uniform? Is it going to be, do you have 1 year to kind of experiment and figure out what exactly is going to work together? Or we're going to just build feature after feature after feature after feature, and we're going to scale. So we need a very flexible solution, okay? Or we have no idea what we're building. So we're going to build something and we're going to iterate. Now, if you do not have the money or the time, or let's say the energy, or let's say, the vision of 6 months ahead, you can just pick up something like WordPress. You can just pick up something which, which gives you a lot of things from default, by default. It might not be very scalable, very performant, but it gives you a lot of stuff from the get-go. And as things start sticking, as you start observing the behavior, that is when you start extracting things out of the original tech stack and start rebuilding it, okay? The decision will always be around how soon do we have to recreate, and not whether we have to recreate or not, because you will have to recreate, okay? Products go in the recreation mode again and again. Just yesterday, for example, Facebook announced its desktop site, which went into a complete overhaul. It's a completely different product altogether. The original product was yucky. It was great looking in 2008, 2009 when it was introduced, but it lived for 10 years. 10 years. Okay, that's like a few light years in the web, in the internet world. But it survived 10 years, and finally yesterday or day before, Facebook finally introduced a new version. I'm not sure how many of you have checked it out, but check it out. I think they have used React through and through. Why React and why not something else, etc., etc. I'll explain that in the future sessions. I will leave the class today. In the last class, I mentioned a certain homework. I'm not sure how many of you did it. In today's class, I'm going to give you a different homework. Very simple homework, but let me share my screen, and I'm going to give you a quick homework here. Okay. What we're going to do here is, the homework here is that you set up or clone a Git repo. Okay. So I spoke about, so for example, here is a very simple project repo on Microsoft, made by Microsoft on GitHub. Okay, it's called Project HTML Website. It's a repo. What is a repo? For the time being, just imagine that it's an online folder, just like Google Docs. It's a folder in which some amount of code is available, which you can download and you can use. Okay, you might think that it is, how crazy is that? Why would somebody put out a code? But it is crazy. After all, Microsoft paid $7.5 billion for this. Anyway, so let me just quickly download this. So what you have to do is go to your machine. I'm going to use HTTPS, and I'm going to copy this simply. I'm copying this. I'm going to the terminal. So if you do not have the terminal, please download terminal. If you're using Windows, then I think terminal is different. I think it's PuTTY or something. Go to the machine. I will jump into. Okay, I have too many folders here. Okay, let me just see if I have projects. Yes, I have projects. So let me just jump into the projects folder. Okay, and let me just clear this out. And I'm going to create a new folder. Let's say tech for PM. And I'm going to cd. I'm just doing this because I'd like to keep things clean, nothing else. So I'm within this folder. There's nothing in this folder right now. Let me clone this down, and just like that, I have a folder created within this folder, Tech for Managers, which is called Project HTML Website. So I have brought down some code from a website called GitHub, and I brought it down to my machine. Okay. If I cd inside this, then you get this. And you can see there's CSS, there's fonts, there's image, there's index.html. And if I open this index.html, let me just see if I have this. Yep. So see, I have this machine, this index.html running on my machine. As simple as that, right? It's an HTML file. And lastly, I will quickly open this folder to show you something very interesting. This is called, by the way, this is called Visual Studio. I really like it. It's a very good tool, surprisingly made by Microsoft. It's a beautiful tool. I've completely shifted to Visual Studio from here on out. And here you can see the folder, you can see project HTML. And if I click on index.html, this is the code for it. Okay. Right. This is the entire code for it. There is the CSS. You can see that CSS have been linked here. It is right here. This is the CSS. This is how CSS looks like. There's fonts and there's images, but yeah, we will talk about images, etc. in future. So the homework for the next class is to do the same exercise on your machine and get to at this point where you can copy over the file. In very simplest form, you can simply either use PuTTY or terminal, or you can use Visual Studio. I will recommend to use PuTTY or terminal because that will kind of prepare you better. Or you can just use this as well, Visual Studio as well, to download a folder from the web. Right. So this is where I stop for today's class. I hope this was useful and something that you learned. Open for any questions, and I'll stop sharing. Okay. So folks, you can switch on your cameras also if you want to talk, or you can simply ask what kind of questions you have. No, Yasha. So access to server by default doesn't give access to database. Database is a different beast. Server is a different beast. Server's job is to simply accept request and give response. Database's job is to store the data and provide access to it on demand. Okay? Nothing else. So if you have the access server, that doesn't mean you get access to database. Okay, what else?
How steep is the learning curve for PuTTY?
Sorry, what?
How steep is the learning curve for PuTTY?
PuTTY is it? Okay, so I have not worked on Windows since about 8 years now, 9 years now. So PuTTY, I think, has improved a lot since 8 years back. So it takes a little bit of time, but I think there's a few million users of PuTTY. So I think you are in safe spot. You'll easily be able to find how to use PuTTY. Right. In fact, I think, if I'm not wrong, I think Microsoft has they have launched a Linux type terminal. So terminal on Windows. I think Windows 10 has a terminal, the new Windows terminal. Yes, they've introduced one,
It's called
which can be
PowerShell,
used.
right?
PowerShell, yes, 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 correct. They've introduced something. It just 1 year back they introduced this PowerShell. 11 months ago, in May 3.
Yeah, PowerShell is more user friendly. I think pretty simple.
Correct. Yeah, but more importantly, it introduces the same stuff like the Linux and the Linux command line and Mac command line. It provides the same features in Windows. Otherwise, it used to be a big pain. Otherwise,
Thanks.
yeah.
Uh,
Okay.
What's
So,
the output?
Talvin-
What's the output for the code you showed us?
So the code that I showed was simply an HTML and CSS code, nothing else. So its job is just to render an HTML into a browser. That's it. That's all it does.
Okay. So how do we see the output there? Like, is there anything?
No, I just showed you the output, right? I showed you the desktop. When I opened the index file,
Okay. That's the output. Okay. Yeah,
that is
got
the
it.
output. Yeah, the
Okay.
HTML job is just to, so HTML just provide the structure that, okay, this is where the image should show up, this is where the body should show up, this is where the footer should show up.
Okay.
It just
Okay.
sets the structure. And CSS job is to make it look beautiful. So CSS is like makeup.
So we can also see the same on inspect element, right? For any website.
Yes, exactly.
Yeah, Talvin, so one question here, just pretty much not in line with that. So what is that? Maybe you have pretty much experience in that for authentication and authorization. Like, what is this open source like tools which you prefer to use on a particular application development?
So see,
ಆಗ್ತೈತಿ. ಬಂದ್ ಆಗ್ತಾ ಇದೆ ಬಟ್ ಬರ್ತೇನೆ ಬಿಡು.
okay. I have no idea what somebody else said. Okay. So for authentication, open source, I think most of the programming languages come with their own OAuth methodologies. So OAuth is I'll just type it down. So OAuth is I'll not call it a framework, but it's essentially a methodology through which you can authenticate people very safely and authorize people very safely. And it is implemented in multiple different ways. Sorry, I think I sent it only to Zed. 1 second. Yeah, OAuth. Yeah, so it's a methodology, and OAuth is used in different ways in different implementations. So if you use PHP, for example, it has its own PHP with Zend. For example, Zend is a framework, PHP framework. Then it will provide a different authentication method. If you use Python with Django, it will provide a different authentication method. LDAP is another one. For example, yes, there is Active Directories, for example, right? So there are different authentication methods that exist, but it typically depends on the server side frameworks that you're using, at least in the initial days. As you scale up a lot, you start to isolate your authentication separately, because that same authentication would be used across your iOS, across your Android, across your web app, desktop app, and all the other apps, right? So
Yeah.
as you grow, then you start separating it out.
So, Talvin, so for example, like the website for pragmatilators, right? So what the idea is, like what I'm thinking is that you are maintaining some user database, right? For example,
Yes.
my email ID and my password is something
Right.
which you authenticate to know,
Correct.
okay, this guy has registered, I mean, he has paid for it and he has done the registration. So that there's one aspect of authentication. Okay, so you are authenticating it. And then there's one aspect of authorization. I mean, basically
Right.
you are authorizing me to access some particular course. So for that, you will be maintaining some kind of databases, right? So these two always like go hand in hand. So what I was like trying to just figure out, because
Understood.
I wanted like some framework right now, because in my like current application development, I use a Microsoft one, but it's like a paid one, because you know, right, all Microsoft things really are very, I mean, costly. And
Correct.
so I was like
So
looking into that line.
so I'm not so at the moment, because we ourselves are using node based and PHP based authentications and authorizations. So that's why we have not looked at a standalone authentication authorization solution. But let me just break this down for you. That's a very good question, Zaid, because that kind of brings out something very interesting. So I'll just leave you with the terms, and then we can cover that maybe later. So there is something called RBAC. Okay, RBAC is a short for role-based access control. Okay, so authentication is simply whether the person is authenticated to come visit me. That's it, right? So you are allowed to enter my house, but that's it. You're not allowed to touch anything. You're not allowed to sit. You're not allowed to speak, but you're allowed to come inside and have a look. It's pretty much like you entering a, let's say, diamond shop. You can come inside, you can point at everything, you can say that, oh, that is good, that is good, that is good, but you're not allowed to touch anything, correct? But let's say you are a wealthy guy and it shows you are wearing a Rolex and you are coming in very nicely, then you can pretty much touch anything, right? You are allowed not just to enter the shop, but you are also allowed to touch anything and take it in hand and inspect it, etc., etc. And as obviously the roles change, you can give more or less access control, right? So RBAC is the term used for this kind of access control. Typically, so nowadays there are ready-made open source libraries which you can use to create this RBACs, but you'll have to hook it up. It just gives you a framework. You'll have to hook it up completely from scratch. That for this role, and it is very, very painful. Okay, and if you have to build it out completely from scratch, it's very, very painful, because what ends up happening is you'll build functions you'll build functions. Each feature would be in the form of functions, right? And so for every single function that you will be making, you'll be testing whether this particular role has access to use this or not. And if not, then what is the error or what is the response I should be sending back, right? And as you can imagine, as things grow and you have like maybe 20, maybe 50, maybe 100 different roles, and let's say, I don't know, 500 different functions in your code base, or 5,000 functions in the code base, you multiply that and it's a nightmare, right? So you have to build very good, strong coding practices to ensure that this doesn't spiral out of control. Okay. So Zaid, if you look up RBAC, you'll get a sense of this. But in a nutshell, there are roles. These roles are connected with access controls. That is, if the user is an admin, he's allowed to do everything. But if the user is an editor, then the editor can only edit somebody else's post, but cannot, let's say, delete the post, right? Can make it private or public, but cannot delete the post, for example. So the delete function, wherever it was, right? The delete function, wherever it was, you would not allow access of that to the editor, right? But the admin will have access to that delete function. Correct? Broadly, this is how it works.
Okay, so Talvin, just to add one more question here. So does the client side, like for example, I'm using this Angular 8 for my front end. Do they have this, I mean, authentication like inbuilt, I mean, there at least any inbuilt framework from Angular?
Angular by default should not have it. Okay. I've not used Angular personally. I do not know. But as far as I know, Angular by itself would not have it. Okay. Because Angular is just a front-end framework. Okay. Angular will rely on the server to power the authentication. Authorization is a very critical function, and that's why it should be done at the server end. If it happens at the front end, then it's a very risky, because it's prone to getting hijacked or hacked. Correct? You would not want to have it in the front end, right? Prasanna rightly pointed out that there are, RBAC, within RBAC, there are roles, then roles are assigned to, roles have groups, and then groups have responsibilities. Okay, that is broadly how it goes. Okay, I can hear some noise. Please mute yourself. There are two very popular services out there. One is, of course, Amazon Cognito. If you just go through their feature set, you will kind of understand how it kind of works. And this allows you to have very clear identity management and stuff for your app and your users, and they have a lot of security protocols, everything taken care of. And there's another very popular one called Auth0. If you don't want to be in the if you don't want to pay Amazon tax, then you can go to auth 0, and auth 0 abstracts out the entire authentication thing for yourself. Yeah, Sandeep, you're right. Auth 0, it does, it becomes a layer in between. It becomes a layer in between your services and your users, right? Correct. So there is two-step
So
authentication. There is three-step.
So Auth0 is like providing the set of APIs which I can use in my this thing for authorization.
Correct.
Okay.
Correct. No, so Zafar, no. So hosting doesn't bind to a particular stack, but yeah, so you can choose to have the authentication uh, in a separate layer altogether. Just like you are using EC2 for hosting and S3 for, let's say, storing the files, you can also use Amazon Cognito for authentication, for example, because authentication, given today's state of the affair, authentication is very, very risky. The cybersecurity, etc., is becoming very, very costly, and you do not want to mess around with that. So you would rely on experts like Auth0 or Amazon Cognito to run it. So you will run it as a separate service altogether, and it's a fair service. It's a fair thing to do because it's a very costly thing to maintain if you want to build it from scratch and you want to run a scalable product, for example. Make sense?
Thanks.
Right? Yeah, and yeah, you do not have to, you're not exactly binded by a particular stack, but yeah, if you're using a backend, let's say PHP or Python or something else, then they typically come with their own authentication and authorization layers. You can use that directly. Most of the frameworks have this authentication authorization layers baked in, so you can use it directly. But of course, if you do not want to use it because you don't want to handle it yourself, then yeah, you can outsource it to Auth0 or Amazon Cognito. There are some open source tools also, which I can't recall right now. Right. I'll take up a couple of questions more and then we can pause. I think we have already gone way beyond. Okay. So the questions kind of end here. I mean, there are a few other questions, but I think
one more question, Tavendra, if I may ask.
Please go ahead.
You were talking about the email client. So I'm like, if nobody's asking, I was just, I mean, it will pretty solve much my office problem also. So I was looking into like something basically it's like a B2B application which we are trying to build, right? So I was looking into something like, for example, if a customer is logging into a dealer website, right, and he wants to buy a particular product, so he needs to register, and then basically we were looking at that point of time automatic email registration. So I was just like
automatic email registration. What does that mean?
So basically, like, I mean, if he has not logged in and we will try to ask him to log in, or if he's not a sign, I mean, if he is not a log, I mean, basically, if he doesn't have a login credentials available, we'll ask them to sign up. So if we are asking them to sign up, so basically it should trigger automatic mails where he will be informed, like as for you, like, I mean, there are mails
Understood.
which are being sent to me. So
Understood,
what
yeah.
kind of like email client, I mean, is like available?
Okay,
or like,
so what you're doing here is, so there are multiple ways to solve what you're doing. Okay, number one, you can use a standard authentication authorization kind of a framework, which it could be Auth0, it could be Amazon Cognito, or it could be one of the open source ones. If somebody knows about any of these open source ones, please do talk about, do share with me. Right, I'm not very well aware. But you would use one of these layers to actually take control of this authentication and in checking whether the email actually exists in your database or not. If it does, great. Ask him to log in. If not, then ask him that, hey, you need to register, and then get him to register. And at the time of registration, you will send them an OTP, or you will send some private link, magic link, so to say, which is sent to that person's email, and he has to log into that email and click on that link so that the person can access. Now, when this is happening, a lot of stuff is happening behind the scene. Essentially, if you remember that hash thing which I mentioned in the previous class, something similar is happening. A unique token is being generated and it is being sent to you. and you are able to, it is appended in that email link that was sent to you, and you click on it, and then the system is able to detect whether the right person has come in from the right referral link or not. Okay, so a lot of these things happen. My suggestion is don't do it yourself. Try to pick up some of the existing frameworks because it's a little complicated and it's easy to mess it up. So that's why just don't do it by yourself. As regards to what client to use to send that email, there are plenty of clients that are out there. You can use SendGrid. SendGrid is pretty good. You can use Mailgun. Mailgun is also very popular. You can use that. There are plenty of, the keyword you're looking for is transactional emails, not promotional emails. Transactional emails. And transactional emails job is to simply send the email as a response to a transaction. Something was purchased, something was refunded, something happened, event is upcoming, etc., etc. So all the transactional stuff. Promotional emails are all the marketing emails that you send, like the newsletters of sorts. Okay. So in your case, you will handle it two ways. One, you can use a full stack solution like Auth0, etc., which will take care of emailing, etc. Or number two, you can just handle the authorization at your end, and you will use a separate email client which provides the transactional emails, and you will hook them up. And when the authentication is successful or not successful or something, then you can trigger a certain email. For example, on Google and few other places nowadays, you get an alert if you are logging in from an unknown device or from a new device, then you get a notification, right? That somebody tried to log into your account from an unknown device. If it was you, it's all cool. If it's not, report it here, right? So Google and everybody has started doing it. It's a very good practice to have. I hope I answered your question. Right. So I will pause here. There are a lot of questions to ask and to answer, but we will take this question maybe on Slack later on. Thank you everyone for joining in. I'm actually surprised to be very honest. These are very dense topics, and everyone is here. That kind of gives me makes me happy that it is being heard. In the next sessions, we will start breaking down the tech stack. Today, it was largely overview of what all things happen, what is tech stack consist of, and what are the different things that exist. We will not be able to cover up every single nuts and bolts of the tech stack because there's so much to cover, but we will start covering individually some of them which are important for you to know, which will be important for your job as well. Okay. Take care, guys. Have a good night.